Wendy. Welcome back. Hey, Ryan, welcome back. Good morning, Nadal. Hi, Ellen, welcome back. Hey, Frank, welcome back. Good morning. Jumila, welcome back. Bellman, welcome back. Do your exit passes. You missed several of them. Make them up. Hey, Kai, welcome back. Hi, Michael, welcome back. Hi, John, welcome. Joseph, welcome back. Hey, Irvin, welcome back. Hi, Tintin. Good morning, Jordan. Welcome back. Hey, Asim. Welcome back. Hey, Tristan. Good morning. Hi, Nadina. Hey, Santino. Welcome. Hey, Emma. Happy Monday. Hello, Kim. Hope you're doing well. Hi, Micaiah. Welcome back. Morning, Phil. Hey, Faith. Welcome back. Hi, Zin. Welcome back. Yeah, don't forget to make up your exit passes. Don't forget to complete them. I think you missed a couple. Hey, Alex. Welcome back. Happy Monday. Alex, you sounded good in the school performance. The band? Is that alto sax?
Tenor sax.
Huh?
It's tenor sax.
Oh, yeah, tenor. Okay, I played the sax. I played all three of them. I like the baritone the best. Tenor, I like too, the tone of it. All right, welcome back. Hopefully you guys are doing well and staying safe. I'm looking for Leonardo and Joseph. If you're here, please let me know. And I could fix it, obviously. All right. So first things first, I went through the 5-week grades, and I noticed several people are missing their exit passes. And those exit passes is basically how I grade you guys for chemistry. Those are like the essential thing. There's no tests. There's benchmarks, but there's exit passes and obviously participation for the notes as well. But that's about it. So if you're missing 1 or 2 or 3 or 4, 5 exit passes for 5 weeks, then you're going to be not happy with your 5-week grade. So reminder, please don't forget to do these exit passes. I don't really give you a lot of time. I don't give you time in class to do it, but that's your homework, that's your quiz. Exit passes, there should be topic 1, 2, 3, 4, 5, and 6 for this quarter. So again, ionic properties, topic 2, topic 3, naming compounds, there's another one. I will definitely start putting exit passes up here for everything, just so you know it is an exit pass, not a warm-up. I'll title them. So topic 2, topic 3, topic 4, topic 5, topic 6. And some of you guys sent me a message the other day. I made a mistake up here. I made types of reaction examples due on Saturday. That was like examples that we're going to do in class, but we didn't have time to do that. I extended that to this week. Obviously, that did not count towards your grades. Thanks for letting me aware of that. But that did not account towards your overall grade for 5 weeks because I wouldn't do that to you. Let's just face it. I don't send you many curveballs. So if you pay attention to class, the examples we do in class, the notes we do in class, then your exit pass should make sense if you're paying attention. Stuff like the types of reactions, I wouldn't throw you random questions like that if I never taught it. Hopefully you know me by now, at least through the computer. All right, before I get to that, let's just check out the COVID update for today. So here's our Oneida County dashboard COVID screen for it, database. Just 5,043 cases. So we're up to 5,043 cases in our county. That is growing, folks. So be safe, be smart. If you have plans this week, holiday plans this week, protect yourself, be smart. Maybe when grandma, grandpa come in for Christmas or whatever holiday may be, maybe don't greet them with a big hug or a big kiss. I guess that's how you can say. I don't know. But just be smart. A lot of COVID around. I'm sure that number is higher than that too. There are 133 people in the hospital systems in Oneida County, in Rome and in Utica. There are 16 people in ICU with COVID. And the other day, there were 6 more deaths to the tally. So those families are definitely, think of all these families that are like losing people right now for COVID. Definitely going through a lot with those families. Hopefully you guys are okay, and hopefully your families are okay too. Let's check out the daily positive number. Total cases. You could definitely, as the weeks keep passing, you could definitely see the curve starting to form. I'm glad that this curve isn't really increasing week by week. I'm glad it's not going. Well, it's not going. So far, I'm glad it's not going straight up. If I were looking at this curve, I take an average of it. Looks like it's starting to form. Hopefully it plateaus real soon. I don't know if it plateaued yet. But the thing that scares me are all these numbers here. All these cases. It could easily go straight up pretty quick. But we've been not stuck. We've been in the 200 to 300 range for the last few weeks of cases. All these people that get the COVID, they could easily spread it. A friend of mine was diagnosed with COVID. He had no symptoms of COVID. He had a rapid test. And they told him initially that he had COVID. But the Oneida County is so overwhelmed, like no one calls to say, hey, you need to stay home. You have COVID. None of that's going on because you have 200, 300 people, all these people diagnosed. It's going to take a heck of an army to really approach all these people and tell them, hey, you have to stay home, protect your family, protect everybody else around your community. Nobody's doing that. So they're expecting the population of Oneida County to be smart enough and empathetic enough to protect everybody else. So is that happening? I don't know. Is everybody in this little range that has COVID being smart about it and not infecting anybody else? I don't know, but I would guess probably not. So that's a big population right there. All right. So anyways, he had no symptoms. He got diagnosed with COVID on Friday. And that's where he stands. I'm sure you know somebody in your family or around you that has. I know several people. When you have numbers of this magnitude, there's going to be more and more people you're going to know. All right, so here we go. Hopefully you had a great weekend. Let's check out the daily agenda for today. The quote of the week: may your days be merry and bright. May your days be merry and bright. All right, daily agenda for today, Monday, December 21st, 2020. It is a day 1. We are continuing on with chemical bonding. Today, we're going to talk about types of chemical reactions. So there we go. Finally talk about types of reaction. It should be a relatively light day. Don't think this is going to take too long to get through all this material. We have a warm-up we're going to start off with. Then we have a flick on types of reactions. Then we have a flick on types of reactions. And then we'll add some add-ons to our notes, analyze some examples, and then hopefully have time at the end of class to give you to work on the exit pass. That's the agenda for today. There's a flick we're watching too. We're going to start off with a warm-up. Please open up the warm-up, 12-21-20 warm-up. This should be a good review on what we've been talking about for ionic bonding. I like these warm-ups. I never did warm-ups like this before, but I think with this platform that we have right now, I think this is a good idea to have more and more warm-ups. Like, I'm not doing a unit test. This will like substitute for questions that you may see for the unit test. I'm not grading it, but I'm expecting you to kind of follow along and do your part as well. I'll do my part. Hopefully you're over there at your house, settled in, doing your part too. So I'll give you 10 minutes to work on the warm-up. So at 1:01, 1:02, we will go over this warm-up. Please work on it. 1 o'clock, we'll go over it. 12:01, we'll go over the warm-up. Please work on it. Okay, hopefully you had a chance to go through those 5 questions. Question number 1 reads, a substance that does not conduct electricity as a solid, but does conduct electricity when melted is most likely classified as what? Please put your answer in the chat. Okay, a bunch of A's and a few D's. All right, bunch of A's. Oh no, I lost my thing. Darn it. All right, so a bunch of A's and a couple D's. So when you have a metal and a non-metal, it's an ionic bond. As a solid, it conducts as a solid does not conduct electricity. As a liquid, if we melt it, it will have the ability to conduct electricity. So non-metals, they never have the ability to conduct electricity. So these guys, no matter what phase they're in, they're never conducting electricity. A molecular compound is going to be a covalent bond. So that's 2 non-metals bond together. And a metal will conduct electricity in a solid or a liquid phase. So all these metals will always conduct electricity in a solid and a liquid phase. So number 1, best answer is choice A. Number 2, an ionic bond forms between atoms of what? Please put the answer in the chat. Thank you, Faith. Thank you, Tintin. Thanks, Alex. Emma, thank you. Asim, Nadina, thank you. Yeah, so all the answers I have so far were B. Ionic bond has to be between a metal and a non-metal. KCl. Let's find them. There's my K. There's my Cl. Metal, non-metal. Best answer would be B. I know you can't click on it, but B is the right answer. Number 3, the GFM. I gave it to you before. If you saw my screen. NH4Cl. The GFM. Hopefully you saw my screen. I can't get it back again. It was 53.5 grams per mole. Does anybody want to see that again? Should have got choice C. 53.5. Oof. You got it. No problem. So here we go. Let's go through it quick. Somebody asked to see the GFM. We should definitely be aware how to do GFM. It's not going to go away. If you can't do the GFMs, then it's going to be tough. All right. Here's one request. So here we go. So NH4Cl. We're right on out here. When you're doing the GFM of NH4Cl, the first thing you want to do is have the ion. After the ion is going to be how many atoms or the number of moles. And then after that is going to be the mass to the tens place. The first element we're analyzing is nitrogen. How many nitrogens? There's 1. What's the mass of nitrogen? It comes from the reference table right there. And to the tens place is going to be 14.0. Multiply them together, you get 14.0. The second ion is H in the compound above. How many moles of H? There's 4. The mass of H, top left corner, is going to be 1.0. 4 times 1, 4.0. And then Cl. How many Cl's? There's 1. Mass of Cl is 35.5. 35.5 times 5 times 1 is 35.5. Last thing you have to do is add them all together. Add them all together. Bring that on down. There's your 5.5 plus 4 is 9, 10, 11, 12, 13. plus 1 over here. So 53.5 AMU or grams per mole. Hopefully that helped whoever asked for the help. I know who did, but make sure you know how to do that because you see GFM for a lot of questions. If you can't do GFM, you're not going to be able to do moles. You're not going to be able to do percent comp. Make sure you know how to do it. All right, so 3 we figured out. It's 53.5. Number 4. Clear my board. In a sample of solid BaNO3 the ratio of barium ions to nitrate ions is what? Please put the answer in the chat. Thanks, Faith. Tintin, thanks. Seam, thanks. Thanks, Kai and Alex. Awesome. So my first class got this right too, and I never really went through this, and I kind of throw these more challenging questions as the unit progresses, if it's challenging. We want to know the ratio of barium to nitrate. So we have to figure out what the heck nitrate is. Nitrate is NO3. And I want to figure out how much barium to nitrate. So how many bariums do we have present there? We have 1 barium. How many nitrates are there? There's 2. That's a 1-to-2 ratio. 1-to-2 ratio. For every barium, there's going to be 2 nitrates. So they could have said Ba, pretty Ba, you know, Ba2, NO3. Then you could figure out what this number would have been as well. So that was multiplied by 2. That's going to have to be multiplied by 2 as well. That 2 is going to be multiplied by 2. So now it's 2 to 4, which actually would break down to 1 to 2. Well, there you go. Best answer there is choice B. Next up, last one, percent comp. I got pretty darn close to finishing it on up. Please put your answer for the chat for the percent of oxygen in CO. Thanks, T. Thanks, Kim. Thanks, Joseph. Thanks, Emma. Wendy. Thank you, Asim. B's. Bunch of B's. Does anybody want to see that one? 57%. You have to do the GFM first. If you have to do the GFM, once you do the GFM, it's part over whole times 100. Last call for number 5. Okay. You do not have to submit it. Choice B was number 5. That's it for the warm-up, so you don't have to submit it. I'm not grading them. You'll notice I'll just start put as review, so it shouldn't pop up anymore after the day's over. So that's not going to be confusing. So there's the warm-up. Hopefully you did okay with that. Now let's get on to our next thing up, types of chemical reactions. Okay, here's a YouTube flick on types of reactions. This is an intro for today's lecture. Enjoy.
Take a deep breath. We'll identify the different types of chemical reactions together. Hello everyone, I'm Melissa Maribel, your personal tutor, and the first type of chemical reaction is known as synthesis or combination. Here's an example. In a synthesis reaction, 2 different reactants combined to form our product. Note, the reason why hydrogen and chlorine have a 2 subscript is because they are known as being diatomic molecules. Diatomic molecules are atoms that exist in pairs. Here is a list of diatomic molecules. Now, if we flip this synthesis reaction, you'll see it's now a decomposition reaction. Because in a decomposition reaction, you have one reactant that is being broken apart into multiple products. The next reaction is a single replacement or a single displacement reaction. Here's an example. Our reactants are 1 element plus 1 compound, and those form 1 element plus another compound. Notice that we are just switching the metals to form our new products. A double replacement or double displacement reaction is really similar to this because our reactants are now two compounds and those form two different compounds. Think of it this way. The inner elements combine and the outer elements combine to form our new products. Or you can think of it as the metals are switching again to form our new products. Up next is a combustion reaction, which occurs when something is burning. This is the general equation. And here's our example, where our first reactant consists of only carbon and hydrogen. Or we can have our first reactant consisting of carbon, hydrogen, and oxygen. Your biggest clue that something is a combustion reaction is that the second reactant is O2, and our products are carbon dioxide and water. These never, ever change. Now, in an acid-base neutralization reaction, we have an acid plus a base, and those form a salt and water. Now, if you're unsure what an acid, base, or salt looks like, an acid typically starts with an H, or hydrogen, and a base will end with OH, or hydroxide, and a salt is a type of ionic compound which consists of a metal and a nonmetal which have opposite charges. Predicting products is the next thing you're going to need to know, so here's a video to help you out. And remember, stay determined, you can do this.
All right, so there are chemical reactions that we will definitely analyze today in class. Everything but the last one for chemical reaction. So here we go. Let's go through our guided notes. Let's figure out where we left off, and we'll start taking some notes on them too. So please open up your guided notes. This portion of the notes, there's nothing there, so we're gonna have to fill it in with types of reactions. So that last one, that video, I think that was a pretty cool video where you could actually see the type of reactions happening there. The last one's gonna be a whole unit on it, so we're not gonna go through that one right now. We will, but not right now. So please figure out where you left off. I think it's like page 20, maybe, page 19, 20. So it's right before covalent bonding. So figure out where you left off, and I'm gonna see what it says. I'm gonna title this next portion topic number 7, chemical reactions, types of chemical reactions. So topic 7, types of chemical reactions. We did introduce this back in the atom, but here we go. We're going to see it now. Types of chemical reaction. I'll blow that up, bold it. And what we're going to do today, we're going to draw like several different reactions. We'll identify it to make it a little bit easier to figure out what's going on here. We will be doing one for addition.
Did you do that, the topic 7 type of chemical reaction, or is that part of like the last
No,
one?
I had to throw this in here.
Okay.
I had to write that in there. I didn't put it in the guided notes. This would have been like a topic where I would like pass out a different piece of paper and do the examples with you, but what are you gonna do? So topic 7, types of chemical reactions. We're gonna analyze the synthesis or addition, a decomposition, single replacement, double replacement, and combustion. So there's 5 different ones you will see. Underneath that, I'm gonna add some cells. I'm gonna insert table, and I'm gonna add 5 different cells here. I'm going to make these tables a lot bigger, probably about the same width as that or height as that. If I highlight them and I go to table properties, I just don't know what size I want them to be at. Minimum height, if I go to there, I may put, let me see what 2 looks like. I guess it's okay. 2 is not bad. Or you could change it to something smaller if you want to, but it will always make it bigger if you have more text in there. So again, what did I just do? I went to insert table and made 5 different tables. I highlighted all that. I right click my mouse or 2 fingers down in the mouse keypad and table properties. I change the height, minimum height. I'll do 1.5 this time. Doesn't make a difference. That's fine.
Can you show how you did that again? I'm confused.
Yep. So I'm going to insert table. I'm going to add 5 different columns. So scroll on down to 5. 1 times 5. 2 times 5 give you 2 different columns by 5. 1 times 5. Highlight those columns, those cells. Go to right click your mouse or 2 fingers down your keypad. You should get this. Table properties. Click on minimum height, minimum row height. I'm gonna change it to 1.5. Anybody want to see that one more time? Throw it in the chat if you want, or unmute. I don't care. Yes, please. Yes, please. You got it. All right, I'll try to go nice and slow this time. Insert. Now go to table. Scroll on to the table. Scroll on down to 5. Click it. Click that right there. 1 times 5. Boom. You could leave it just like that if you're confused. That's fine. Or highlight it. 2 fingers down your Chromebook or right click your mouse if you have a mouse. Go to table properties. Click on minimum row height. And I'm going to change this to 1.5. If I did like 5, it'd be like whoosh, big. 1.5 is big enough. If you need more help, you might want to Google that or YouTube that or ask a friend. You're welcome. All right, so the first type of reaction is going to be called an addition or synthesis reaction. So to differentiate these 5 different reactions, I'm just going to paint each cell, kind of like what I did up here, just so I know there's a different reaction for them. You know, I like to color code things. You don't have to color code it. It's fine. I'm going to click inside the cell. I'm going to my dot, dot, dot. Then I'm going to go to paint can. I guess I'll start off with, I'm going to go light colors this time. A light red, whatever. I'm going to call this one reaction number 1. It is synthesis or addition reaction. Synthesis or addition reaction. This is a combining of 2 or more elements or compounds to make a larger one. Combining 2 or more elements or compounds to make a larger one. You're taking 2 things and you're combining them. You're synthesizing them. You're adding them together to make a bigger one. The format for this, I'm going to hit center now. Let me get a little cray-cray here now. Let's just change my font now. Get cray-cray. I don't know. No, I don't know what to do. I'm going permanent marker. The format would be like A plus B yields. So it's element A plus element B. It yields, combining together, A, B. A plus B yields AB. So if it has that setup right there, you're taking 2 things and combining them together. That's an addition or synthesis reaction. I'm going to do something else this time. Now I'm going to go to insert Drawing, no. I'm gonna represent synthesis reaction with some atoms here. So I'm gonna color code different atoms. So what I'm gonna do, I'm gonna take shape. I'm gonna make an atom. So I'm gonna start off with one all the way to the left. I'll color code these as well. And I'll say, hey, that's element A, because I'm gonna use these color codes for the rest of today's lesson, really. So I'm gonna use the same color system. So there's element A. I add A in the middle. I'm gonna add a text box, A plus. And then I'm gonna copy this last cell that I made, that little circled atom. I'm gonna paste it over to the right, just so it's the same size. It doesn't have to be the same size. I'm gonna change the color of it though, to blue. And then in the middle, I'm gonna call that B. So A plus B, add another text box to put yields. That's my reactant so far. Yields. Guess I'll blow that up so it's more proportional. A plus B yields AB. So these elements are by themselves in the reactant. I'm going to copy my A, Control C. I'm going to copy and paste it, Control V. Don't click off of it right now. Just drag it on over with your arrows to the right. A plus B yields AB. So I'm going to copy my B and paste it over to the right. So you should be able to look at this and say, oh, these to the left are elements, and to the right, they're going to be combined together. They're joined together. That's going to be a compound. So when two elements combine together, they're added together to make a compound. That's a synthesis or addition reaction. A plus B yields AB. Does anybody want to see how to do anything there again? One down. Easy. That is an addition reaction. I'm going to use the same color system for the rest of these for the other reactions. Anybody need more time? Joey. Good morning, Joe. Welcome to the best class of the day. Try to get here a few minutes earlier next time. Let's get an appointment. Alex, let me know when you're good. So there's the first one. Joe, we're taking some notes on topic number 7. It's right after percent composition of a hydrate. We got to actually add these notes in here. So synthesis or addition reaction, boom, done. Combining two things to make a compound or something bigger. This could be a polyatomic ion plus another polyatomic ion to make one big, something bigger. Good luck with that. Technology sometimes challenging. All right. Hopefully that was enough time to get through synthesis and addition reaction. The second one on down, the next reaction is going to be called decomposition. I'm going to color code this. Let's go orange. Decomposition. The next one, decomposition. Sounds like something's breaking on down. This is exactly what's happening in a decomposition reaction. Decomposing. Something decomposes. You have a decomposed area at your house. Maybe you put your coffee grinds, your apple peels, apple core, banana peels all in there. That's going to be a compost area. It's going to eventually be breaking down. So decomposition is going to be the breaking down of a compound into simpler elements or compounds. You're breaking it on down. Breaking down of a compound into something small. You can't break down, it can't be a compound or element because elements can't be broken down any more than what they are. So it's got to be like a compound breaking off to smaller components. What I'm going to do here, I'm going to copy my image and my setup from above. I'm going to copy that and I'm going to paste it below. So copy, then below I'm going to paste it here. I'm just going to mock it or doctor it up a little bit. So again, what I just do, I highlighted my picture and my format from above. I clicked Control C to copy and clicked Control V below to paste it. Just because I want that font, I want the same little elements. This setup, if you think about it, breaking down the compound into smaller ones, it's going to start off with a compound. So it's going to be AB, a compound. Two things together is a compound. By itself, it's an element. When they're fixed ratios, it's a compound. AB in the reactant yields A plus B. So decomposition, you're breaking that thing, that compound, down to smaller or simpler things. Once you have that, I'm going to double click my image to recreate it to make it look appropriate. Double click on it. And decomposition was A, B. Guess I'll just drag this to the other side. If you highlight your A, then use your arrows, you can just bring it together to form a compound. Oh, this might be challenging. Oh, it does work. All right, so I have that situation, there's two compounds. A compound yields a compound. That's not decomposing. So again, try to highlight just your B. Try to bring it on over to the right, and then we could smush a little addition right between. So that's tricky. Try your best. You really just want to highlight inside your little element there. If you get beyond it, then it's going to expand beyond and get more. Just try to get your element. That would represent the format for decomposition. Decomposing. Decomposition reaction. Save and close. Boom. I'm liking the way this is working out so far. The next one, the third type of reaction, is called a single replacement or substitution. I'm going to change the color of this one just to differentiate it. This is called single replacement, typically. Or it's also called substitution. You'll hear both ways. And in a single replacement or substitution, it's going to have the format of an element plus a compound yields a new element plus new compound. The element plus compound yields a new element and a new compound. I think my example will make it a lot easier to understand this one. Okay, what I'm gonna do, I'm gonna copy and paste the image above, copy, and paste it again, just like we did the last time. We're gonna mock it again. We'll make it fit. So we have an element plus a compound. So it's gonna be A plus, let's say B, C. Element plus a compound. So there's my elements by itself. A compound's a fixed ratio. Yields a new element. So what's going to happen here? It's going to have to substitute. One of these are going to switch on out. So this guy's going to jump in maybe with the C, and then maybe B is going to back on out by itself. Or it could be the C could have backed out. It could switch. They could substitute each other. One thing's going to singly replace something else. I'll talk about that a little bit more in a second. So an element plus a compound yields a new element. So we're going to call over to the left, we're going to say it's B plus AC. An element plus a compound, okay, yields a new element by itself plus a new compound's formed there. So this example would be like pre-COVID, like before COVID happened. So if we're just analyzing this little section right here, and maybe that's you, and maybe this is like high school sweethearts. So what happened, maybe there's this, we'll say a couple that's dating. So pre-COVID, maybe these guys went to a party, and then there's a couple there already, and there you are. And then this B says, hey, I actually don't want to be with you anymore. I want to actually be with A. So A and B could be together now, and now C is by itself type of thing. Or A and C could be together more appropriately, and then B could be by itself. This A singly replaced the B. Now A substituting with B, AC is now a couple, B's left by itself. So don't worry about it though. Worry about yourself before you worry about someone else. Take care of yourself first. But anyways, single replacement. Let's change this format over here too. So it's element plus compound yields a new element plus a compound. So I'm going to double click on my image and I'll edit that as well. Okay, I'm just putting that up there for my own little reference, just so I don't mess up the order on this. All right, so we have A by itself plus BC. So we're going to have to change this up a little bit. How am I going to do it? So I'm going to highlight BAB somehow. BAB, hopefully all highlights. Good. Scrolling on over to the right. Why? Because I want to put that addition sign there as well. I go to the text box, add a plus. A plus B, C I'm going to scroll this on over to the right too so I could smush in my C. You could just drag each one of them, but I think it's easier just to highlight them all, scroll on over. I gotta make a C here. So B, C. Guess I'll copy my B. Control C. Control Z's undo. Control C, Control V. Copy, paste. I'm gonna make this one to a C. I'm gonna change the color. Guess we'll go orange. And this atom is gonna be BC. A plus BC yields B plus AC. So take your time to construct this to make this. I thought I was gonna give you some extra time today, but I don't think I'm going to anymore. This is my third example. So try to make it set up the same way above. A plus BC yields B plus AC. Element plus compound yields a new element plus a new compound is now going to be formed. That's what we should have there. That's the drawing you should have. I know it takes time. I didn't think it was going to take this much time, but it is. Not you, it's the technology. Yeah, you could easily draw this on a piece of paper if you wanted to. You could do that. Just don't forget to upload it to the notes. That is a single replacement or substitution reaction. Once you're ready, you can save it and close them. Oh, I was just about to say I'm getting lucky with my saving and closing today too. Hopefully it stays. So if that happens to you, just refresh and you got to scroll on down to wherever you were. Did anybody do anything fun and exciting this weekend? I had a jolly old fella come by in a fire truck in my neighborhood. That was a big highlight for us. Wow, we're at page 26. It's like we do something in this class. Page 26. Oh, I have 26 pages. Page 20. There's my single replacement. Ah, no. Double click on it. Hopefully it's saved. Sometimes, oh, you're renovating your house too. Sometimes when that happens, I just gotta cut it and then paste it back in. So Control X, Control V. Save it, then it kind of loads there for you. What's fun renovating the house, isn't it? Mess. Good times though. I'm sure it looked nice. All right, there's my single replacement. Let's do one more. I'm actually gonna not, maybe I will. I was thinking about not doing combustion, but I figured I will. I'll probably light and load. I'll probably do a couple examples. I'll probably do the examples next time in class, actually. So tomorrow's class, we'll do the examples. All right, single replacement element plus a compound yields a new element plus a compound. What I'm going to do here, I'm going to go to the next one. Does anybody need more time? All right, Alex is good. Thanks for telling me. So I think we're good then. Alex is the only one that replied to me. All right, next is going to be a double replacement reaction. So as you can see, they're getting a little bit more complicated. A little bit more is going on here for the reactions. The last one's called, or last main one, so double replacement reaction. Double replacement. And in a double replacement reaction, what's going to happen? Whoa. It's going to be a compound plus another compound. Those two compounds are going to swap it on out. Yields a new compound plus another new compound. So hopefully you notice that there's no elements at all present here. This one's the most complicated type. Compound is going to be a fixed ratio of 2 or more elements. The setup here, I'm going to copy and paste single replacement, and again, I'm going to doctor it up a little bit. Very close. It's similar to this. So copied and paste the equation above. Now let's change this equation to AB plus CD yields to double replacement. So what's going to happen here in this equation, they're going to swap on out. This A and B are going to switch partners with C and D. So there's one couple dating. There's another couple dating. And then they realize, hey, they're not the good match with each other. Maybe A and C would be a good match, and maybe B and D would be a good match. So they swap out partners there. They switch partners, double replacement. Whatever. Maybe that helps, maybe not. So this is going to be like AC plus BD. A compound plus a compound yields a new compound's formed, plus another new compound will be formed as well. Double replacement. Two things are changing. So let's set up the picture below. I'm going to double click the picture. And I'm going to edit that picture right there. Again, you don't put this in here. I just put it in there so I don't mess up the system, or the color system. So obviously we have to make another atom, a D atom. You have to remodify this drawing up here. AB plus CD yields AC plus BD. All right, first thing I'm going to do is take the plus sign down. I'm going to join A and B together. Use your arrows again. Looks like I have to move A over as well. Need more space. MySpace was a thing back in my day. MySpace.com. Then I realized I spent too much time on it, social media, and then I gave it up. So I focused on college instead. Don't waste your life away on social media. Read a book, they're better. All right, so A, B plus C, and I obviously need a D there. So I'm going to copy my C, paste it on in. I'm going to change the color of that D. Let's go purple. Call this a D element. AB plus CD yields AC I know it's a little tedious today. I really didn't think this was going to take the entire period. But I guess my graphics are a little time consuming. A and C are together now. You guys can do your examples for homework. This is why, because I never taught you yet. AC plus BD. The reason why I spend so much time with this, though, I think it makes it a lot easier. So you can visualize, think about these types of reactions. If you're doing this now with me, then it's going to make more sense that once you see the examples in the exit pass or warm-ups. AB compound plus CD compound yields AC, a new compound, plus BD, another new compound. Again, you can see what happened there. They swapped on out. A and C are now going to be a match. And so are B and D. Double replacement. Okay, once you're done with that one, you can save it and close it. No video filters today. Learn from that one. Sorry, guys. All right, there's your double replacement. No, that's not right. So double click on the image. The image didn't save. I'm going to cut my image and paste it back in, then it should save. Control highlight all, Control X, Control V, save and close. There's my image, the correct image. Let's do one more reaction and then we'll call it quits. So one more reaction. It's going to be a combustion reaction, but I'll give everybody a minute to do this still. Something combust, obviously it's going to give off heat. Combustion, think about it. All right, last reaction, it's a combustion reaction. And in a combustion reaction, the lady in the video talked about it. The main thing about a combustion reaction, the products are always going to be, products formed are water and carbon dioxide. CO2 and H2O. So if you have CO2 and H2O as a product, that is going to be proof that is a combustion reaction. About 90% of the time. Most of the time, it's going to be a combustion reaction. When I did that like plastic whoosh bottle demonstration, I put the alcohol in, I threw the match on top, that little flint on there, and then you saw which bottle? That was a combustion reaction. You had products of water, and if you could smell through your computer screen, you would smell carbon dioxide, definitely present there as well, but we don't have that connection. I'm going to copy that format. I'm not going to make some spheres for this one. I'm just going to say, we'll talk about these organic compounds a little bit later. I'm going to say CX, capital C, subscript X, H, subscript Y, plus O2, oxygen gas. So in order for something to burn, you need oxygen gas, yields water, plus carbon dioxide. This is, that right there is going to tell you it's going to be a combustion reaction. This could be like methane, propane, something that has the ability to burn and give off these products. All right, guys, once you're done with that, I'm going to call it quits for class today. I'm not going to go through examples right now. There's not a ton of time left. So tomorrow we'll do a warm-up. We'll do some examples. I might start balancing equations. I don't really want to go too hard with you guys since it's a holiday week, but figure might as well. We have some time off. We'll see what happens. So I will definitely keep teaching tomorrow. My wife's like, why don't you just play a video? I'm like, I don't feel right just playing a video for you guys. I go, it's my job to hear your teacher, so I'm going to keep teaching all the way throughout. Hopefully you're getting something out of this each and every day. On that note, there's no exit pass yet. You can't do the examples. Like, you could look at the examples, but we'll do them tomorrow in class. So that's it for today. Have a great day. Stay safe. Protect yourself. Protect your loved ones. Be kind to each other. And make good decisions. See you later, guys. Bye. Bye, Kai. Bye, John. Have a good day.
Have a great weekend.
Have a
Mr.
good
Frank.
day.
Thanks, Frank. We'll see you tomorrow.
Have a good day.
Bye, guys. Thank you. We'll see you later. Bye, C. Don't forget to do your exit passes. Grades are due today.